sorry, at any given point our x or the variable x will point at any coordinate that's on the left hand side of the number line. So likewise, this minus x means we're moving on the left hand side of the number line. So minus x is equals to 2 means we are going to move 2 units of the distance that we are going to move is going to be 2 units. So this is going to be 1 2. So we have moved 2 units. Right now the x is currently placed, or the variable or this point is currently placed at the value or the constant coordinate of -2, because we have specifically said that we will have to move 2 distance on the left hand side, which is the negative side. So likewise we can say that minus x is currently greater than 0. So what this means is, if we again go back to the beginning of this third step, is that we are now considering the numbers or the coordinates on the left hand side. So similarly, those coordinates will always be negative numbers or negative values or negative constants. You can say it any way you want. So right now we are considering this to be plus x is greater than 0, just like we have written in here. So these are two notations. You can either write, if we bring that in here, we can write like this, or let me erase that off. Likewise, we can write that negative x is equals to 2. So I have chosen this notation specifically. So this notation is similar to this. You can just write -2 lies below or on the right hand side of 0. So x is less than 0. So at any given point, our our variable x will point to a constant value that will always be less than 0. So this is the similar thing as this, but this gives us a certain value or a certain station where we should stop, or this gives us a certain distance, like we must stop at 2 units. But this generally means that all the values that we are now going to consider will be less than 0, and our variable x will now point to any coordinate at any specific time which is less than 0. So because we are now considering any value on the left hand side of the number line, uh, any value that's contained inside positive x, or more precisely x, then we can say that any value or other values on the other side of the number line will generally be or naturally be considered to be minus x. So these are all relative terminology. So as we have seen, the left hand side, let me erase everything off, it's getting cluttered. So let me clean up the screen. Let's skip this part. Okay, now it looks a lot cleaner than before. So I always lose my cursor. So we are now considering that at any given point, this x, which can also be written as plus x, but for our understanding purpose, we always consider plus x to be x. So this x at any given time points on the left hand side, which contains all the negative coordinates or all the negative constant values. So if this is plus x or if this is simply x, then the values, if we consider another variable, or similarly if we consider the opposite of this x, then we will have to consider minus x, or in here we can write minus x. We can erase that off. So we can say, so this, we are considering the left side to we're considering that positive x now contains values from the left hand side relative to the origin, but negative x will contain all the values or all the coordinates from the opposite side of the number line, and hence the opposite side of the number line contains all the positive coordinates or all the positive values. So hence this negative x is greater than 0. Likewise, this is referring to the right hand side, or uh, this is referring to the right hand side, or we are moving along the right hand side, and on the right hand side all our values will be greater than 0, or all our values will be positive. That's why we say let opposite value be denoted as minus x greater than 0. So the reason is that we have already considered that positive x will refer to all the negative constants, and negative x will refer to all the positive constants. I think that makes things clear. So likewise, the other steps are similar. We're going to consider the left hand side like this. So the left hand side was minus x, and we're going to apply something like placing opposite value of x, value of x as minus x. We can write this in a bracket. So hence we will find that this, let me break this bracket, let me break these bars right now, and hence we can also take that value and minus x, I'm writing this again, and then in this minus x we will apply something like this, the bracket, and hence we can say that I have actually made a small mistake in here, so let me erase that off, because previously we worked with the opposite values, which are the positive values, so we considered the left hand side. Now because we are considering all the negative values, we must consider the right hand side, so I didn't notice that. So let me erase all of them. Let me bring up my pen again, and right now we're going to consider the right hand side. So the right hand side looked something like this, the absolute value of x. Let me take off this bars. Right now we can say placing opposite value of minus x. So hence if we place minus x inside this x, then we get something like this. So this brings us to the conclusion that we can write this as minus the absolute value of minus x. So we can then determine that this left hand side is equals to the right hand side, or in this case, in this third step, the right hand side is equals to the left hand side, as you can see, and we can also write it like this. So this was all about rule 1. Next we shall look at rule 2.